Hey, good afternoon, everybody. Thanks for being with us today. We are going to be talking all things energy conservation with ultrasound. So if you've been kind of following along with our series of webinars we've been doing, we've tried to hit most of the applications or all of the applications that ultrasound covers. So we've done a webinar that was kind of a ultrasound 101. We've talked lubrication. We've talked remote and continuous monitoring, electrical last week, and so now we wanted to dive into leak detection, steam trap inspections, things like that. So if you missed any of those other webinars and you wanted to check them out, we do have them all archived on our YouTube channel and our website, so you can check those out there. But Adrian Messer will be presenting that for us today. Before we dive into that, those of you that have been with us the past couple of weeks, you've heard this, but those that are new, just want to remind you guys that we're definitely here at UE Systems to be a support, always, all year round, not just during this kind of crazy COVID time, but we do pride ourselves on providing first class support to our customers. So if you have any needs with software training, or you want to talk through different applications or help with procedures, anything that you might need related to your ultrasound program, reach out. Let us hop on a WebEx or a Zoom meeting, whatever you want to use, and we'll go through it. We certainly miss the face-to-face time with our customers, and I know our guys miss being out on the road and being able to be with you guys. So I think some of that's opening up a little bit. I know some of our guys were out and about this week, so hopefully we'll get to start seeing more of you guys in person. But in the meantime, as some of us are still kind of locked up at home, we'll try and be here virtually for you guys. So definitely take advantage and reach out to us if there's anything at all we can help with. So I am recording this, just like I mentioned. All the other webinars that we've been doing are all recorded as well. We definitely welcome questions, so you can type those in. I'll keep an eye on those and toss those over to Adrian as it makes sense. And of course, at the end, if we don't get to all the questions, don't worry, we'll be sure to follow up with you guys offline, so we can continue the conversation that way. And as I say, actually today I've only got one dog in the house and no kids and no husband in the house. So hopefully the one dog will behave. And don't worry, I didn't kick them out. They're just taking advantage of campgrounds being opened up, and they're off camping. So hopefully we'll have a nice quiet house here today, but if not, or if we have any audio issues or anything like that, we'll jump on those things just as quick as we can. Just part of the risk or the fun of doing these things live with you guys. So with that, Adrian, I'm going to turn the screen over to you, and we'll let you take it away.
All right, let's get going here. Let's see. All right, can you see that okay, Maureen?
Looks perfect.
Okay, awesome. Well, again, good afternoon. It's a pleasure to be here with you again for one of our other webinars. Thanks for attending. Thanks for taking time out of your day to be here. We are getting back to the basics here with this topic. What I mean by that is these applications that we're going to talk about are some of the easier applications to implement using ultrasound. We think about these ways to reduce energy in our plants. That doesn't always have to be a major capital project where we're spending a lot of money and we're going to have a long return on investment. If you already have our equipment, or if you already have an instrument in-house, I guarantee you the same instrument that you have, you'll probably be able to do a lot of these same applications that I'm going to talk about. So again, it doesn't have to be a major project to reduce energy within our plants, but using ultrasound for these 5 applications, you can have a pretty quick return on investment and show some really good savings with probably something that you already have in-house. And again, if you look at, kind of this time that we're in, a lot of you will probably have some of these energy projects that will be coming up, because we're all going to be looking for ways that we can save money. And again, these are great things to do with a technology that you've got in-house. And even going back to the founding of UE Systems, if you look at UE Systems, really kind of what propelled us to be where we are today goes back to energy initiatives that took place back in the late 1970s, where a lot of people wanted to focus on energy savings. And again, it really just kind of helped UE Systems to become who we are today and really advance the technology forward. So if we think about, reducing energy waste and inefficiencies, a lot of us, a lot of you on the call today have probably been in your plant or, your respective facility for some time now. And, when you've worked in the same place for years and years, a lot of times, you just kind of get used to the things being the way they are. You get used to hearing the sounds of those air leaks, or, when you're driving into the plant, you don't always look at the rooftop if you've got steam in your facility, if you see excessive steam venting to atmosphere. We just kind of get used to some of these things. But, really, if you look at an energy efficient plant, you can directly relate that or directly link that to the overall reliability of the plant. So again, if we focus on reliability and if we try to be better at reliability, make energy a part of that. And a lot of times it parallels, they parallel each other. Common sense, again, just paying close attention, when we're out walking our plant floor, don't have blinders on when we're out walking the plant. Walk with the purpose of looking for ways that we can do things more efficiently, mainly with compressed air. Sometimes we go into these plants and we see people using compressed air for things that just don't make sense, like cooling a motor or cooling a fan, sweeping the floor, moving parts. Think about ways that we can do that same task, but yet do it more efficiently using another method. And really what I like to focus on, and some of the things I'm going to show you today, are going to be reporting and documentation. Again, a lot of times people don't notice maintenance until something happens. Something fails, and then fingers come out from everywhere, and they're looking at maintenance and they're saying, why did you let this fail? Well, if you have your proper reporting and documentation to where you can say, hey, we found this failure 6 months ago, but you chose not to do anything about it, or you said we need to keep running, then, again, you've got your reporting, you've got your documentation that kind of backs up your case. It's the same way with energy. If we're out looking for compressed air leaks, for instance, instead of just saying, hey, we found 20 air leaks today, I'm going to show you how we can put a dollar amount to that today. Same with steam traps. So again, when you put a dollar amount to some of the things that you're doing in terms of your maintenance and reliability related tasks, then it helps to create awareness, it helps to create buy-in, and it really showcases maintenance as being an overall value instead of a cost center. Now, if we think about ultrasound, ultrasound is really a kind of a broad term for the technology, but there's three kind of separate divisions of ultrasound. So if you're not familiar with the technology, again, here are the three forms of ultrasound. Now, at UE Systems, we deal in airborne and structure-borne. So unlike pulse echo and power ultrasound, we're not emitting anything, but we're simply a listening device. And we're listening for high-frequency sound either through the air, such as a compressed air leak or a vacuum leak or some sort of electrical noise that we may be picking up coming from inside an electrical cabinet, or structure-borne. So structure-borne being where we are going to make physical contact with a bearing housing or a steam trap or a valve, and that allows us to be able to listen to what's taking place within that steam trap or that valve or that bearing. So again, at UE Systems, we deal in airborne and structure-borne. Again, we're listening for high-frequency sound, sound that's above the range of normal human hearing, and we're listening for that either through the air or by making physical contact with the piece of equipment that we're inspecting. So then there's different sources of high-frequency sound that we detect with our ultraprobe instruments. So with leak detection, the source of the high-frequency sound there is turbulence, where you have something under high pressure that's trying to exit out through a small crack or orifice in a pipe, for instance, to low pressure or atmosphere. That creates turbulence. Same you have turbulence created with vacuum leaks, with air in leakage. And then you can have internal turbulence, say across a steam trap. So if we're listening to a steam trap and that trap cycles open and releases condensate, that creates turbulence. So we actually hear when the steam trap opens, and then we're going to hear when it shuts back, if it's a trap that is designed to cycle that way. Same with a valve. If we're listening to a valve and the valve is supposed to be closed, we're going to be able to tell if there is turbulence across that seat of that valve, where you have flow that's being restricted through a smaller orifice on the outlet side of that valve. That's going to create turbulence. So we'll be able to tell if that valve is leaking by or not. Then you have ionization. Ionization is going to be with our electrical inspection applications, to where we're able to listen for and detect corona tracking and arcing from inside enclosed electrical cabinets. So again, a great use of ultrasound and infrared together. We see more and more people using ultrasound as kind of the first line of defense. So we listen first prior to opening up any kind of enclosed electrical cabinet. And we're going to be able to hear if there is a potential fault taking place inside of that cabinet before we open it up. So a lot of people are using ultrasound for safety-related applications, because if you do that approach, then we're greatly reducing the risk or the chance of an arc flash. But again, it's not relying solely on one technology or the other, but it's making use of ultrasound and infrared together, and you're pretty well guaranteed to find just about any electrical fault that may be occurring. And then with equipment reliability and condition monitoring, we're primarily listening for friction and impacting. One of the applications we're going to talk about is condition-based bearing lubrication, and that directly relates to friction. And then impacting primarily with slow-speed bearings. And again, it's where we see a lot of people using ultrasound and vibration together is, if you already have existing vibration routes, but if you're not currently using vibration on slow-speed bearings, ultrasound is a perfect fit for that, because it's super easy to do. So what happens is, when you have these slow-speed bearings, if you have a fault that starts to occur, that fault will sound like a click or a pop or a tick or a screech. And then, of course, we're going to hear that in the headset. And if you're using an UltraProbe 10,000 or 15,000, you have the ability to record the sound of that slow-speed bearing. And when you play that sound file back and look at it in the time waveform, those anomalies will show up really nicely in the time waveform. So again, turbulence, mainly with leak detection, ionization with electrical faults, and then friction and impacting with bearings. So again, we don't emit sound, but we receive, and we're listening for high frequency sound. So the picture you're seeing over here on the right is our SCM, or the scanning module. Should look familiar to you, especially if you're using an UltraProbe 2000, a 9, a 10, or a 15. Those scanning modules will look identical to that one. So what you see inside of there, you see, in this case, an array of 3 of the piezoelectric crystals in there. So those are what actually sense and receive the high frequency sound. And when those crystals sense that high frequency sound, they flex and bend, and that produces electrical energy. And then there's a process that takes place inside of the UltraProbe called heterodyning, or basically it's a translation. So it basically takes the sound that we can't hear and translates it into an audible that we would then hear in our headset. So if we're using an UltraProbe and we're scanning an area for a compressed air leak, we're actually going to hear the sound of the air leak. If we're making contact with a valve or a steam trap, we're actually going to hear the operation of that valve or steam trap directly in our headset. But all of that takes place because of the heterodyning concept. So again, it's a translation of that high frequency sound into an audible that we can hear in the headset. That electrical energy also produces our unit of measurement for sound, which is a decibel level. So once we've located that compressed air leak, we get a decibel level. So that air leak is making noise. So we can measure the decibel level. If we're making contact with a bearing, we're going to get a decibel level reading. So now that's something that we can track and trend over time to look for any kind of change. And probably one of the more important things that I'll tell you today will be the recommended frequency settings. So again, if you're using an UltraProbe 2000, a 9000, a 10, or a 15, or even the UltraProbe 401, the digital grease caddy, those UltraProbes have frequency tuning capability. So what I mean by that is we can tune or adjust the frequency according to what the application is. So the 4 frequency settings that you see here are the ones that are recommended for some of these applications. So if we're going to go out to do airborne leak detection, we want to make sure to have our frequency set to 40 kilohertz. It's the same for airborne electrical, also at 40 kilohertz. For structure-borne mechanical, meaning bearings, we recommend a frequency setting of 30 kilohertz. And then for steam traps and valves, we recommend a frequency setting of 25 kilohertz. And again, just for reference, we get these frequency settings, or if you're looking for a source of reference, there is a recommended standard for ultrasound. It's an ISO standard. It's ISO 29821. So these are kind of a globally recognized frequency settings for the different applications. But again, that ISO standard is a standard for recommended use and guidelines for ultrasound. So again, just for reference, and if you're looking to kind of start a program, if you're looking for, again, a set of globally recognized standards and guidelines, then that would be a great place to start. So what makes ultrasound so great? Well, one, it's very directional. So we can go out in a typical plant environment, and because we're listening for high frequency sound, sound above the range of what we're capable of hearing, we're not really concerned a whole lot about ambient or background noises. Now, in some cases, there are sources of competing sound or competing ultrasound, so we just have to be conscious of those. But because high frequency sound is very directional, meaning that it doesn't travel far from the source, it makes it very easy to locate the sources of these different sounds within a typical plant or facility. And we'll talk about a way that we can use to actually pinpoint where that sound is coming from. And all of our instruments are going to have a sensitivity adjustment. So when we get into compressed air and compressed gas leak detection, we'll talk more about that. But again, because we're listening for these high frequency sounds, ultrasound is very directional, meaning that it's very easy to pinpoint the exact source of where that sound is coming from. And again, in most cases, we don't have to be too concerned about plant ambient background noises. We're talking about bearings. When I say here allows for an early warning of failure, if we're using ultrasound for a bearing condition monitoring program and we're trending the decibel level over time, any sort of change, any subtle change in the condition of that bearing is going to change the decibel level. So if we're trending the decibel level of that bearing and we start to see that decibel level increasing, that's a really good leading indicator of a potential problem. And if we know the amount of increase either above a baseline dB reading or above the previous reading, we pretty well know what the condition is. We can tell if it's just a lack of lubrication, if the bearing needs grease, or we can tell if that bearing is now in a failure mode that is beyond a lack of lubrication. So again, it's a really good leading indicator of a potential problem. And we'll go back to that concept when we talk about condition-based bearing lubrication. And then ultrasound, aside from being the most versatile of all the condition monitoring technologies, it's also very complementary to those other technologies. So just like an infrared camera sees what you can't see, an accelerometer feels what you can't feel, ultrasound hears what you can't hear. So again, it's just another extension of one of our senses, and it's another tool that we can use to hopefully gather as much information as we can to make a good diagnosis on what the health of that asset is. So again, very complementary to anything that you may currently be doing in regards to infrared thermography or vibration analysis. All right, the number one energy application where we can have or where we can use ultrasound is compressed air leak detection. Still the most widely used application for airborne ultrasound. It's an application where we see a lot of people, if they're not currently doing ultrasound in their plants, they will justify the cost or justify the implementation of ultrasound based off of compressed air leak detection. Even, if you look at, some of the stats here, the compressor companies will tell you that as much as 30% of the compressed air generated is lost to leaks. The compressor companies themselves will tell you that. And then if you look at what it takes to produce it, what you get out of it, and again, 7 to 8 horsepower of electrical power to produce 1 horsepower of compressed air power, it a lot of times can be considered to be the most expensive utility in a typical plant or facility. And some of my visits that I've had in different plants throughout the years, sometimes within a few minutes, we can find and document enough compressed air leaks to more than pay for the cost of the ultrasound tool. So just some things to note in regards to compressed air leak detection. The minimum PSI that's needed for ultrasonic leak testing is 5 PSI. So if you go back to the picture that I showed you of the SCEM or the scanning module, those scanning modules are rated to find leaks at a pressure as low as 5 PSI. You get below 5 PSI and there's just not enough turbulence created to be detectable with an ultrasonic instrument. So as long as we're at 5 PSI and greater, we can do ultrasonic leak testing, regardless if it's compressed air or any other kind of specialty compressed gas. So what I say here by utilize the gross to fine approach, what that means is if you've ever been through any of our training classes, we teach this as a method to locate where the compressed air leak is coming from. So it relates back to that sensitivity adjustment. So again, if you're familiar with our instruments, all of our instruments have a sensitivity adjustment. So at the maximum sensitivity setting, that's going to give me the most broad field of view to be able to scan an area. So when I go out into my plant, I want to pick out an area where I want to scan for compressed air leaks. I can stand back several feet away and I turn up the sensitivity. In most cases, we want to kind of increase that all the way to the maximum sensitivity. And then I just simply scan that area left to right. So I'm holding the ultra probe in my hand and I'm scanning left to right. I'm scanning up and down. And we really kind of use our ears as much as we are our vision. So the sound will actually lead us in the direction of where that sound is coming from. So if we detect a leak or if we hear a leak, we want to lower the sensitivity. So we're going to narrow that field of view and we're going to continue to scan in all directions. And then eventually we're going to be able to pinpoint exactly where that field of view or where that leak is coming from. So again, we take our field of view from a very broad field and we narrow that down to where we're able to pinpoint where that leak is coming from. So we call that the gross to fine approach. Now, when we talk about in the next slide how we're going to quantify the compressed air leak, when the research was done for this, going back probably 20 years ago, and it's really become an industry standard way to quantify how much that leak is costing, one of the factors that's built into that formula is the distance away where we want to take that decibel level reading. So once we've located exactly where that leak is coming from, we want to back away approximately 15 inches from the end of the rubber focusing probe, and we want to take the decibel level reading from that distance. So again, when it was found, or when the research was done, it was found that the optimal distance that would get you as close to the actual dollars loss and CFM loss for that leak was approximately 15 inches. If you take that decibel level reading too close to the leak, it tends to overestimate how much that leak is costing. So just something to be conscious and aware of, that if you're going to do the reporting for this, again, once we've located exactly where that leak is coming from, we just simply back away approximately 15 inches and take the decibel level reading from that distance. So again, that formula, how we quantify these leaks, it's based off of the decibel level, the pressure, and then our cost per kilowatt hour of electricity. So how much it's costing me to generate 1,000 cubic feet of compressed air. All right, so one of the things that I wanted to kind of highlight here is we do have a leak survey app that's available. So if you go out into Google Play or if you go out into the App Store and just search UE Systems, one of the apps that you'll see is the Leak Survey app. So right from your phone or your tablet, we can do our own compressed air or compressed gas leak survey, and we can generate this report that will give us the dollar amount and the CFM loss for each one of those leaks that we find. So when we generate that report, the first tab that's going to come up is the one that you're seeing here. So it's our cost tab. So this is where we would specify the state that we're in. So also built into this, we have some energy information that I'm going to highlight momentarily. So we would just specify where we're located. You can see here's your electricity cost. So in this case, we're looking at 10 cents a kilowatt hour. We'll get into some of these other numbers here, but you'll see there's your compressed air cost. So how much it's costing me to generate 1,000 cubic feet. And the report is going to default to an annual basis. So you see here your operational times, 24/7, 365. So if we know the compressed air is going to be shut off certain days, we can adjust our operational time there. So, but again, the default is going to be an annual or a 24/7, 365 basis. So here's a closer look at the report, and this survey, I actually did this little survey while I was conducting a training class for a plant that's fairly close to me where I live. And in about an hour's time, we went out and we found a total of 13 compressed air leaks. So right on the app, we were able to enter the location name. We specified they were all compressed air. The pressure, they were all 75 PSI except for one leak here. So here's the decibel level that we noted from the ultra probe. Again, we entered some additional location description information here. But these 13 air leaks at 10 cents a kilowatt hour were costing this plant nearly $6,800 per year. So again, and that was just in about maybe an hour, maybe a little over an hour's time. So again, significant savings, and we did all this right through the Leak Survey app. All right, the number 2 application where we can have, again, very quick payback and show some very good energy savings is with compressed gas leak detection. So if your plant has specialty gases like, say, argon, helium, hydrogen, nitrogen, you can see some of the costs here. So argon, some of the latest numbers that we've heard, as much as $23 per 1,000 cubic feet. Helium, tremendously expensive gas, could be as much as $100 per 1,000 cubic feet. Hydrogen, as much as $12 per 1,000 cubic feet. So in some cases, one leak that you find with an ultra probe may pay for itself. Obviously, there's going to be some safety reasons why we need to do these leak checks on some of these compressed gas systems, environmental reasons. And I'll tell you another great application where I saw being used was in a plant, and they had their specialty gases delivered in bottles or the cylinders. So what they were doing is when they would get a shipment of those bottles or those cylinders, they would actually take their ultra probe and they would just do a quick scan of those bottles and cylinders to make sure that they weren't accepting in any leaky cylinders. So I thought that was a great application. And the day that I was there, they actually found a couple of the, dozen or so that were delivered. They actually found a couple that were leaking. Now, where the compressed air leak report, the formula, it was based off the decibel level, the pressure, and the cost per kilowatt hour of electricity. This is going to be based off of the decibel level, the pressure, and then the cost of that gas. So how much we're paying for that gas, so a dollar amount per 1,000 cubic feet. So again, going back to the Leak Survey app, You saw previously, here's your compressed air, but then underneath that, we have it set up for some of these other specialty gases. So you see argon, helium, hydrogen, nitrogen. If you're using anything other than that, you can just simply rename one of these to whatever that gas is, and then you would just enter in your cost per 1,000 cubic feet of that gas right there to the right of that. So again, here's a little survey that was done where we found 3 nitrogen leaks and then 2 helium leaks. And again, you'll see the cost of those gases here. But those 5 leaks that we identified were a little over $27,000 per year. So again, one leak that you find with an ultraprobe on some of these specialty gas systems could potentially more than pay for the cost of the tool. And again, that's all generated right through that same leak survey app. All right, number 3 is going to be carbon footprint reduction. And I know a lot of plants that I visit, they have people in place that they want to track their greenhouse gas emissions. They want to track their carbon footprint reduction. It all relates back to sustainability. So again, in these times, we're all looking for ways to be more efficient, to be more pro-environment, to be more environmentally friendly. And this is one great and easy way to showcase that. But if you look at, in just the United States here, if you look at the carbon footprint and the greenhouse gas emissions, industry accounts for a lot of that. Transportation obviously is a big chunk of that, but electricity and industry accounts for nearly half, or right at half, of the carbon footprint or the greenhouse gas emissions in the U.S. So again, going back to that leak app and the report that's generated, if you look over as far right as you can, the last 4 columns in that report show the greenhouse gas emissions. So how much the greenhouse gases are directly related to these wasteful compressed air and compressed gas leaks. So that's why we would specify where we are. So like in the United States, we got all that information from the Department of Energy on a state-by-state basis. So the DOE has their own formula that, based off of how the electricity is produced within that state, they can determine what the greenhouse gases are based off of how clean that energy production is. So if you're in a state where it just happens to be more, say, coal-related or fossil fuel-related, compared to a state where you may have more, say, nuclear or hydro or wind power, it's going to be a little bit cleaner. So again, all that information in that report came from the Department of Energy on a state-by-state basis. So that's why we would specify the location where we are. And that report will actually track your greenhouse gas emissions that are directly related to those leaks. So for example here, if you look at the report, you have a repaired yes or no column. So right now, all of these leaks are showing no's because we haven't repaired any of them. But if we go in here and we start to repair these leaks, we can just change the no's to yeses. And then that in turn will update the spreadsheet. And then you have a report tab at the bottom that will then show your progress. So we can see not only the amount that we've saved, we can see the CFM that we've gained back, but then we can also see how much we've reduced that carbon footprint by. So again, all that's directly related to that leak survey app report. Okay, the number 4 application where we can show very quick return on investment and show some really good energy savings related to our plant is going to be with steam trap testing and inspection. So a very similar report, or a very similar statistic, just like the compressor companies, the 30% loss to leaks. Here, the DOE also says that a typical facility can realize steam savings of 20% by improving the steam system. And improving the steam system includes doing an annual steam trap survey of our traps. I've heard a lot of similar number from some of the steam trap manufacturers that say, kind of a rule of thumb is if it's been longer than 3 to 5 years since you've done a steam trap survey, then as many as 50% of the steam traps in your plant could be failed. And failed meaning either leaking by steam or failed open, so continuously blowing steam. And, some plants that I visit, they may only have 20 traps, but you may be in a plant, if you're in a chemical company or a refinery or any kind of, process related type plant, you may have thousands of traps. So the potential could really be significant. And it's one of the easier applications that we can use ultrasound for. And here is that stat. Again, 20% of the steam leaving a central boiler plant is lost via leaking steam traps. The biggest, factor with steam is going to be trap identification. So that kind of leads us into this steam trap testing and reporting app. So what I mean by trap identification is walking up to a steam trap and identifying what type of trap it is. Because based off of the type of trap, that will determine what it's supposed to sound like. So, for example, if you have an inverted bucket trap, a disc-style traps, thermodynamic traps, those types of traps you'll hear a very distinct cycling. So, if we're making contact on the outlet or the discharge side of that trap, when that trap cycles open and releases condensate, we're going to hear that, but then we'll also hear when it shuts back. And then a few seconds later, typically, we'll listen to the trap, we'll hear it cycle open, and then we'll hear it shut back. Now, your other sound characteristic comes in with your float and thermostatic traps. Your float and thermostatic traps are not designed to cycle open and then shut. Your F&T traps will have a more continuous flow, but yet a modulating continuous flow type of sound. So typically on your F&Ts, you'll have an inlet up on your top. Then you have kind of this curved housing where a ball float sits at the bottom of that trap, and then you'll have an outlet just past that ball float. So what happens is as the level of condensate changes within the trap, that kind of produces and creates that modulating continuous flow sound. So again, your sound characteristics with ultrasound when it comes to steam traps will either be on and off or hold, discharge, hold, like your inverted buckets, your disc, your thermodynamics, or continuous flow or a modulating continuous flow like your F&T traps. So if you go out again into the App Store or Google Play, one of the apps that you'll see, if you search UE Systems, will be the Steam Survey app or the Steam Trap app. Very similar to the Leak Survey app in that this really becomes our steam trap database. And for a lot of you that have steam traps, a lot of times that's the biggest challenge is just knowing where all the traps are because things have been added to and taken away. So, you can really build your steam trap database based off of this app and report because we can also incorporate photos of where the traps are, what the traps look like, maybe the nameplate of the trap, the model number. So we need to know a few more things in order to be able to quantify how much the steam trap is costing, just because we're dealing with a different type of matter, if you will. So it's a little easier with compressed air than it is for steam, but we need to know the type of trap, we need to know the orifice size, and we need to know the inlet temperature and the outlet temperature. Now, if you're using an UltraProbe 15,000, it makes it super easy because it has the built-in spot radiometer. So we can take those inlet and outlet temperatures, and then we can enter that information right on board the UltraProbe. But the formula kind of built in behind here is if you're familiar with steam, the temperature kind of equates to the pressure. So the higher the temperature, the higher the pressure. So the formula in behind here uses that inlet and outlet temperature as kind of those pressure readings, and then the orifice size. And then based off of our test result with ultrasound, so we've checked it with temperature, and now we're gonna listen to it with ultrasound, and based off of our determination, we're going to note if that trap is okay. Is it working properly? We're going to note that if we hear steam bypassing the seat of the trap, meaning that it's leaking by, we're going to note if it's failed open, and we're going to note if it's failed close. So based off of these pieces of information that we enter into the app, it's going to generate me a report that will look exactly like this. So small little report that we did here where we only looked at 5 traps. But out of the 5 traps, you can see that we had 2 that were leaking by, we had 2 that were failed open, and we had 1 that was okay. So aside from entering that information, the only other piece of information that we need to know is how much it's costing me to generate 1,000 pounds of steam. So somebody at your plant, somebody at your facility knows that. And just, I've heard numbers anywhere as low as $10 per 1,000 pounds. And I've heard as high as $18 per 1,000 pounds. So a lot of it just depends on the fuel used to generate that steam, how clean it has to be. I guarantee you some of your higher numbered costs of steam will be in your pharmaceutical types of plants, to where the steam has to be very clean, has to be treated, so things have to be added to it. And then typically the fuel used to generate it is going to be a little bit higher than it would be if you're, in other types of industries. But in this case, we had a cost of steam, so $10 per 1,000 pounds. But these 4 traps, so we had 1 that was okay, and then the other 4 that we determined were, failed or not working properly, were costing this plant a little over $4,700 per year. And again, that's on an annual basis. But that was just 5 traps tested. Like I said, you may be in a plant where you may have thousands of traps. So I would say at a minimum, you should be checking your steam traps on an annual basis. All right, number 5, and certainly, last but not least way that we can use ultrasound to increase, or reduce energy waste in our plants or facilities while increasing reliability, directly relates to mechanical efficiency and friction. And again, we're kind of lead into talking about condition-based bearing lubrication. And, again, if you look at this stat here from the U.S. Department of Energy, motor-driven equipment accounts for 64% of the electricity consumed by U.S. industries. So, again, we all have motors. Why not make them as efficient as possible? All right, so now also directly related to friction, we have heat. So increases in friction, it's going to create more heat, and that's going to directly relate or contribute to the energy loss. We're going to use a greater amount of power to overcome. And related to that, increases in temperature, it causes expansion. So that's going to cause excess wear and tear on our bearings. And, if you look at over and under lubricated bearings, it's, again, a source of friction. So when you have a bearing that either needs grease, that's going to be an increase in friction, but then also bearing over lubrication increases friction with our bearings. So if you look at these bearings here, or let's say this motor here, first of all, both of these motors that are shown were lubricated based off of timed intervals. So the person that was responsible for greasing these motors, they didn't intentionally apply more grease than what was needed. They weren't the type of person that said more is better, but they lubricated this motor, or these bearings on the bearings on this motor, based solely off of the time-based lubrication PM that they were given to do. But obviously you can see that it was too much too often. And then if you look at the picture in the middle there, that those bearings, again, you start to see that scoring, that spalling there. That's directly a friction and temperature related bearing failure mode. But when we use ultrasound for bearing lubrication, an ultra probe or a grease caddy, it's going to let us know when we've applied enough grease or if we've started to apply too much grease. So the concept here, again, if we're listening to a bearing, either with a grease caddy or an ultra probe, And if that bearing needs grease, then what we want to see is, if we're watching that decibel level, we want to see that decibel level falling as grease is added. So once it drops down to a more normal, steady level, we stop greasing. There's no reason to keep applying grease to see if that decibel level will come down any lower. It's not typically going to happen. Now, what happens is, if we go out to lubricate a bearing that is already sufficiently lubricated and doesn't need any more grease, then ultrasound is going to give us a pretty quick response, in that if we start to apply more grease than what's needed, the decibel level will start to increase. So if we're ever noticing that on our grease caddy or on our ultraprobe, then we know that we need to stop applying grease, because we've reached the threshold now to where we've started to apply too much grease. So the picture here that you're seeing, both of these are screenshots from our spectralizer software. And they were from sound files of bearings that were in the process of being lubricated. So the top picture here, starting over on the left, you see how the noise started out very high. So we had a very high amplitude or a high decibel level. But then gradually, as grease was added, the amplitude or the decibel level fell back down to where it should be, and we stopped greasing. Now, the time waveform that you're seeing on the bottom, a little bit longer of a sound file, but you see, again, starting on the left, you see a very high increase in amplitude. Grease was added. We had a very nice fall back down to a more normal level, but they continue to apply grease to that bearing. So again, when we start to over lubricate that bearing, that in turn creates more pressure and friction inside the bearing housing, and therefore more noise. So they over lubricated this bearing for sure. So if we're ever applying grease and the decibel level starts to increase, we need to stop applying grease. So the move here is more towards condition-based lubrication rather than just simply basing it off of timed lubrication intervals. So just wrapping up, I wanted to be sure to leave some time for some questions if we had any that came in. But again, when we think about the reliability of our plant, energy savings, energy conservation should be a part of that, because it's been shown that an energy efficient plant more than likely is going to be a reliable plant. Ultrasound can play a major role in helping to reduce energy waste. Again, all 5 of these applications that I've presented to you today are super easy to implement. Just through some basic training on the ultraprobe that you have, anybody in your plant or facility can go out to do any of these applications that we've talked about. So it's very easy to deploy, and it's going to be some of the applications where it's going to give you, if you do the right reporting and documentation and showcase that, again, it'll help to showcase maintenance as a more value add than a cost center. And it'll help to improve the overall reliability of your equipment, especially directly related to bearing lubrication. If you're in a plant where you know that you have major issues related to improperly lubricated bearings, again, could have a tremendous payback. And not only that, but you can also typically show a 30% reduction in the amount of grease that you're using, because the tendency for time-based lubrication alone is to over-lubricate. So once you add in ultrasound for bearing lubrication, you'll certainly show you'll be using less grease than all the other, effects from that. So you're going to be buying less bearings, you're going to be sending motors out less often to be rebuilt, et cetera. Again, it's about making more with less. And again, in this time, if you're fortunate enough to still be working and if your plant is doing well, we really need to be looking for ways that we can be more efficient, because eventually it really becomes a competitive advantage. If I'm in an industry type where there's a lot of competition, and if I can make a product more reliably, more efficiently, without using as much energy or producing as much waste, that certainly is a competitive advantage. And I talk about reporting and documentation. Track the KPIs related directly to energy usage. So if you're going to go do a compressed air leak survey, track your energy uses. Track track your amperage, how many amps your compressors are running prior to the leak survey. And then once you've gone out and repaired the leaks, see what they're running after the leak survey. I guarantee you it'll be less. And that's just something else that you can showcase and use to your advantage. So with that, we'll open it up for some questions. You do have my contact information here, so I would love to hear from you. If you think of something after the call today, feel free to reach out to me. If you'd like some of the example reports that I showed throughout the presentation, I'll be glad to share those with you as well. Also, as Maureen stated, this is being recorded, so if you want to go back and watch this later or forward that on to a colleague, someone that you know is directly related to energy management, certainly would love for you to share that. So Maureen, do we have any questions?
Yeah, we do. So first I'll just kind of answer again. So as Adrian said, we were recording this, so I'll get it up on our YouTube channel here today. If you want the link to that, you can of course search for it or email Adrian or myself, and we can send you the link when we've got it up. So Adrian, a couple people asking about slow speed bearings and what that kind of minimum RPM is for ultrasound to pick up those defects. So maybe you could answer that.
Yeah, I thought about that. Normally when I'm talking about slow speed bearings, I'll mention that. But yeah, typically with UE systems, we refer to slow speed bearings as anything below 100 RPM, even into single digits. I mean, we have people that are using ultrasound on applications as low as even 1 RPM or 3/4 of an RPM. Now at that slow of a speed, a good slow speed bearing at that level will produce little to no high frequency sound. It won't even register a decibel level on the display. But where you really want to make use of, on that slow of the speed, you'd really want to make use of recording the sound files. So just like I mentioned, the little when you start to show wear fatigue, that metal-to-metal contact or that fault will start to produce high-frequency sound as an impact. So again, a crack or a pop or a tick, and then you'll hear that in the headset. But even still, it may not register a decibel level. But if you look at those recordings in the time waveform, you'll start to see those anomalies showing up really nicely in your time waveform.
Okay, awesome. And someone was wondering back when you were talking about steam traps, kind of how insulated a pipe can be to where you would still be able to pick up that turbulence.
Yeah, that's a great question. Typically, the best place to make contact is going to be directly on the outlet or the discharge side of the trap. So, making contact, with that trap or with the pipe that's closest to that discharge. Now, I have seen cases to where people will create little ports, if you will. So they'll just take a drill and just kind of drill through the insulation. And the thing that I do kind of like about that is the location where we're going to make contact becomes more repeatable. So, we walk up and we see that little port, and they'll plug that either with just a little bit of insulation or just some kind of a covering. They'll just kind of cover that up. But again, we're walking up and we know exactly where it is that we want to make contact. So it does make it a little more repeatable in that we're testing in the same location every single time. But ideally, the best place to make contact is going to be directly with the trap or just the pipe that's closest to the discharge orifice of that trap.
Awesome. All right. So those of you that are asking for, some of the templates and the apps and things like that we've got a lot of good information on our website. Certainly you can reach out to Adrian or myself directly, and we can point you in the right direction to find where you can download some of those resources. So just know that. And I'm going to just take the screen back here from you, Adrian, and just kind of close things out here. So just a reminder that we do have available online courses for all of our applications. So if leak detection or steam trap inspections are something that you're really interested in learning more about, we have courses for both of those. They're really excellent. They were developed by folks who kind of specialize in adult education. So you're not just sitting there watching PowerPoint slides going through. You actually kind of interact with it. There's questions, there's things you have to do throughout. So it keeps you really engaged. And folks that have taken any of our online courses, we get really great feedback. So as you know, conferences and in-person training courses are probably a little bit few and far between for this year. We do have those options for you guys. So if you want some more information, again, you can certainly reach out to me or it's on our website. So if this is, again, a topic of interest, you can definitely dive in even deeper than Adrian was able to get through in an hour today. So just know that. And next week, we are going to dive into the industrial Internet of Things and how that relates to some of the continuous monitoring solutions that we've got here at UE Systems. So if that's something that you guys are thinking about that's of interest to you, we will be doing a webinar on that next Thursday. And so with that, I'm going to pop our contact information up there. There's my email address. Again, our website, uesystems.com, ton of information there. And don't hesitate to call, email, whatever. We're here to help and to answer questions for you guys and point you in the right direction for things that you might be looking for to help, start a program or continue to grow an existing program. Adrian, thanks so much for the great information, and hope everybody has a great rest of your day, and we will catch you guys later.
Thanks, everyone.